It's an important chapter. But you always remember, matter also behave like wave, and wave also behave like particle. Okay. So particle sometimes behave like particle and sometimes behave like waves. And wave also sometimes behaves as particle. Okay. Remember this, these words. A particle has a moving particle. A moving particle
Amma,
has a wave associated with it, means we can say that we can say that particle, we can say that moving particle waves like wave. And one more thing, like just I told you, a particle can behave like wave. In the same way, we can say that sometime we have proved that experimentally that wave behaves like particle. Okay. From here, this chapter will start dual nature of matter and radiation. I hope you all understood. Nature of matter and radiation. Radiation means wave. Okay. So sometime radiation will behave like a particle and sometime matter means particle will behave like a wave. Okay. So we will start this chapter with the photoelectric effect. Now what photoelectric effect will prove? Why we are learning photoelectric effect? Because we want to prove that light sometimes behave like a particle, and light is an electromagnetic wave, right? Do you know that light is an electromagnetic wave? Light is an EM wave. All of us knows light एक electromagnetic wave है, but it sometimes behaves like particle. Okay. To prove particle nature of light, we will learn we'll learn photoelectric effect. Right now, what is photoelectric effect? Let's try to understand what is actually photoelectric effect. When light falls on surface of conductor it ejects outermost electron. This effect is known as photoelectric effect. Okay, right. Note, when we heat when we heat up any metal, some electrons leave surface of metal. This effect, दरवाजे लगाते भाई, दरवाजे लगाते. This effect is known as thermionic emission. तो आप जब किसी मेटल को गर्म करोगे तो मेटल की सरफेस में से कुछ इलेक्ट्रॉन्स बाहर आ जाएंगे. इसे हम थर्मियोनिक. ओके, रिमेंबर, ये पता होना जरूरी है. और जब किसी मेटल की सरफेस पे लाइट पड़े, विजिबल लाइट, तो जो इलेक्ट्रॉन्स बाहर आएंगे, इस इफेक्ट को हम फोटो इलेक्ट्रिक इफेक्ट कहते हैं. ओके, रिमेंबर ऑल दिस. सो हम ऐसा क्यों कह रहे हैं कि अगर लाइट पड़ी किसी मेटल सरफेस पे तो इलेक्ट्रॉन बाहर आ जाएगा, तो इससे लाइट का पार्टिकल नेचर प्रूव होता है. बच्चों, आप लोगों ने कोलिजन पढ़ा है. कोलिजन में क्या होता है? एनर्जी ट्रांसफर होती है, टोटल एनर्जी कंजर्व रहती है, बट एनर्जी एक पार्टिकल से दूसरे पार्टिकल में जाती है या नहीं जाती. इमेजिन टू बॉल्स ऑफ मास m1 and m2. m2 is at rest and m1 is moving. So when m1 will collide with m2, after collision m2 will start moving, right? So what happened here? Some energy transferred from m1 to m2. समझ आया बच्चों? Some energy will transfer from m1 to m2. So overall energy is conserved, but energy will be transferred from one particle to another particle in the collision. Same thing is happening here in the photoelectric effect. In photoelectric effect, we'll understand, we'll consider light as a particle. We'll assume light is a tiny light made of a very tiny particle called photon. And when these photons falls on the surface of metal, they collide with the electron. An electron will take energy from the photon, and by using this much energy, electron will try to come out from the surface of metal. Okay. Now let's try to understand this photoelectric effect experiment. Okay. Right next heading. Draw this with me. We try to maintain very low pressure inside this tube. Let's see what is happening here. By the observations of this experiment, we will learn how Einstein wrote his equation of photoelectric effect, for which he got a Nobel Prize. बच्चों देखना, quartz window क्या करता है? Quartz window will allow only that particular radiation which have energy required to eject electron from the metal surface. Okay, now this is a metal. You are using here a metal. Assume you are using cesium or sodium. Okay, you are using cesium or sodium because it is very easy to eject electron from cesium or sodium. Okay, it is very easy. Very small energy is required to eject electron from these two metals. Okay, now imagine some light is coming on this surface. This is known as incident radiation. This is incident radiation and it has energy as C by lambda, and we can represent its energy by this also, HF, where F is frequency and lambda is wavelength of incident radiation. If this radiation is strong enough, then only it will enter and it will fall on the metal surface. Understood, bacho? So what will happen if this radiation has sufficient energy? And luckily, if this radiation collide with the outermost electron of sodium or cesium or whatever metal we are using, remember, if this radiation collide with which electron? Outermost electron, then only outermost electron will absorb this energy and the electron will try to jump out from the metal. Could you understand that? And this electron already have some kinetic energy, and to make this electron to travel this space, we have given certain positive charge to this side, right? Now what will happen? This electron will move and collide here, right? Here you have vacuum, okay? Still you will get some current. You have vacuum, still you are getting some current, means electrons are coming out from the metal surface. Am I right? Understood, bacho?
Yes, sir.
Okay, now what will happen? One by one electron will start coming from the metal surface. Slowly electrons will start coming out from the metal surface, and the negative terminal of the battery will keep supplying electrons to the metal. Could you understand that? And these electrons will absorb energy from the incident radiation and they will leave the metal surface. Could you understand that? Any doubt in this? Now, one very important observation, bacho. If I increase energy of incident radiation, if I increase frequency and if I decrease wavelength, देखो वेवलेंथ कम करेंगे तो भी एनर्जी बढ़ेगी क्योंकि एनर्जी इज इनवर्सली प्रोपोर्शनल टू वेवलेंथ, और फ्रीक्वेंसी बढ़ाएंगे तो भी एनर्जी बढ़ेगी. अंडरस्टूड बच्चों? If we increase frequency, energy of incident radiation will increase. So if we increase energy of incident radiation, what will happen? Will you get more current? What do you think?
सर इलेक्ट्रॉन अपने स्पेसिफिक एनर्जी को ही एब्जॉर्ब करना चाहेगा.
ऐसा कुछ नहीं है, ज्यादा एनर्जी दोगे तो वो तो लेगा और ज्यादा काइनेटिक एनर्जी से बाहर निकलेगा. समझे?
जी सर.
My question is simple. If we increase energy of incident radiation, the value of current will increase or not?
Yes.
Yes or no? Okay. Now, answer of this question, some students will say yes, some students will say no. But the correct answer is no. If you want to increase current, you will have to increase number of incident photons. On increasing energy of incident radiation, current will not increase. If you want to increase current, you will have to increase number of incident photons. So if you increase energy of incident radiation, current remains same. Okay? क्योंकि अरे तुम्हें इलेक्ट्रॉन कितने निकालने, करंट ज्यादा चाहिए तो इलेक्ट्रॉन ज्यादा चाहिए कि नहीं चाहिए? If you want more current, you want more electrons, and you will get more electron when more photons will incident on the metal surface. Electron तेज निकलेगा. If you give more energy, electron will come out faster, but number of electron will remain same. समझ में आया? इलेक्ट्रॉन तेज बाहर आना और ज्यादा करंट होना अलग अलग बात है. If you want more current, you need more number of electron, right? If electron is coming faster outside, it does not mean that you will get more current. Do you understand that? Huh? So if you increase energy of incident radiation, there will be no effect on current. So if you want to increase current, what you should do?
Number
of incident radiations must be.
Correct. You'll have to increase number of incident photons. Right? Understood, everyone?
Yes, sir.
Okay. So let's write observations. Your first observation is, if we increase energy of incident radiation, very important observation. Current remains same. इतनी भी नहीं बढ़ाई है. ठीक है. If we increase energy of incident radiation, current remains same. Second observation. If we increase number of incident photons, ब्रैकेट में लिखना इंटेंसिटी. See, if you want to supply more photons, means you'll have to increase what? Intensity. If you are increasing intensity, means what you are increasing? Number of incident photons. Remember, and if we increase number of incident photons, means intensity, then value of current also increase in same proportion. Understood? अगर हम नंबर ऑफ फोटॉन्स बढ़ाएंगे तो करंट भी बढ़ते जाएगा. राइट? नाउ थर्ड ऑब्जर्वेशन. If we decrease energy of incident radiation, at some point value of current will become Y. Correct. Very good, Hers. What happens if you decrease energy of incident radiation? After some time, what will happen? These incident radiation will not be able to eject electron, because to eject electron you need minimum energy. Let's say you want 2 electron volt to eject electron. Suppose you want at least 2 electron volt to eject electron, and incident radiation has 1.5 electron volt. Electrons will come out? No.
No.
Could you understand that? So minimum energy required to eject electron is known as work function of metal. Work function of metal means the energy equal to work function of metal you will have to provide to a metal to eject electron from the outermost surface. That is minimum energy required to eject electron from the metal surface. Could you understand that? If you give energy less than that, electrons will not come out. And if electrons will not be coming out, the reading of ammeter will become 0. Okay. Now let's talk about another very important observation. What if you reverse polarity? Observation number 4. Now what I'm going to do, see, be very careful. I am going to reverse polarity. Polarity reverse कर दूंगा. देखिए ध्यान से. जहां नेगेटिव था वहां पॉजिटिव लगा दिया, और जहां पॉजिटिव था वहां नेगेटिव लगा दिया. ये सारी चीजें सही करना होंगी. Everything else is same. Radiation is still coming. Incident radiation is still there. Everything is same, but there is very big change, very big change. Abhi idhar pe, now in this side you will get negative charge, right? Negative potential. Am I right? And suppose you can adjust this voltage. Suppose you have a switch, and by using that switch you can adjust these voltage. Understood? Now what will happen? Tell me what will happen. Electron, if radiation is sufficiently strong, this incident radiation is capable to eject electron will come out. Now what will happen? Electron will reach here or not?
Will not reach.
Some electrons will reach. Fastest moving electron will reach. Now if you increase more potential, अगर आप और negative potential बढ़ा देते हैं, suppose you are getting little bit current, increase negative potential. So when you are not getting any current, that particular potential known as stopping potential. Understood? Right, fourth observation. Right, fourth observation. When we reverse terminal of battery, current reduced. There is no doubt. Am I right? Current will be reduced. But when we increase negative potential, at certain value, current becomes 0. क्यों हुआ ऐसा? Why current became 0? Because this negative potential, ये नेगेटिव पोटेंशियल फास्टेस्ट मूविंग इलेक्ट्रॉन को भी रोकने में कामयाब हो जाएगा. अंडरस्टूड? नेगेटिव पोटेंशियल will stop the fastest moving electron. If fastest moving electron is stopped, then all other electron will be stopped by default. You understand that? है ना? So that particular potential at you are not getting any current known as stopping potential. Right? Note. Can you suggest me another definition of stopping potential?
To stop the electrode or to repel the electrode.
It is that negative potential which can stop fastest moving electron. समझ गए? ये वो नेगेटिव पोटेंशियल है जो मेटल से निकले हुए सबसे तेज इलेक्ट्रॉन को भी रोक दे. Could you understand that?
Yes, sir.
But do you remember from electrostatics, change in kinetic energy is equal to Q delta V, where delta V is potential difference. Do you remember this?
Yes, sir.
Okay. Now assume electron has some kinetic energy, right? And final kinetic energy of electron is 0. Okay. So can I say that the loss in kinetic energy of electron must be equal to E delta V? Because we are doing experiment related to electron. So at the place of Q, I'm writing E. And which potential here stopped electron? Say stopping potential. So loss in kinetic energy of electron, can I say that E into Vs? Can I say this? Yes or no?
Yes, sir.
Okay. Now read this definition. It is that negative potential which can stop fastest moving electron. So can I write here Ke max is equal to EVS? This is formula. By this formula, we can find stopping potential. Am I right? This is formula to find stopping potential. Could you understand that? Electrostatics में याद है ना Ke is equal to Q delta V. कि भूल गए? याद है ना?
Yes, sir.
Okay. So I think there is no doubt till this. कोई doubt तो नहीं है अभी तक? Anvit, everything understood?
Understood, sir.
Okay, that's good. So from observation number 4, we have learned all these things, right? Okay, any observation you want to add from the chemistry side, chemistry theory? You have done this before in chemistry, am I right? So anything else you would like to add in this experiment? Any observation you would like to add in this experiment? No? याद होगा तो ऐड करोगे भाई, कुछ याद है कि नहीं है? चलो आगे बढ़े. Everyone understood this experiment? Can you explain photoelectric effect experiment? I forgot which scientist performed this experiment first time. Hertz. I forgot name of that scientist. I'm sorry. I'll tell you tomorrow. Okay. नहीं हर्ट्ज है क्या कौन है मैं नाम भूल जाता हूँ साइंटिस्ट का कल बताऊंगा विकेश म्यूट करो अपने आप को बेटा आगे बढ़े बच्चों चलो आई थिंक देयर इज नो डाउट है ना टिल दिस अब लिखो basics required to learn photoelectric effect. Now your first basic is energy of incident radiation. एनर्जी ऑफ इंसिडेंट रेडिएशन को हम ऐसे रिप्रेजेंट करते हैं बच्चों hc by lambda, but for fast calculation we will write 1 to 12,400 divided by lambda in Armstrong. So energy will become in electron volt, or else you can write 1240 divided by lambda in nanometer. So you'll get energy in electron volt. Okay, for fast calculation you can write like this. Okay, now answer my one question on the basis of this information. What is energy of red color? Wavelength of red color is 7,000 Armstrong. चलो जल्दी से बताओ. E is equal to 12,400 divided by 7,000. 2020 got cancelled. 1012.4 by 7. बताइए कितना आएगा? Approx 1 point something आएगा यार. कुछ भी यार.
124
कुछ भी करते हैं. अच्छे से डिवीजन करो भैया. मैं खुद कर लेता हूँ. 1.7 electron volt approx. Am I right? 1.7 electron volt approx. Understood? This is how you can calculate energy of incident radiation very fast. Understood, bacho? Okay.
Yes, sir.
Okay. Now write second point. Second point, work function of metal. कोई डिफाइन करना चाहेगा वर्क फंक्शन ऑफ मेटल? श्रेया?
Sir, minimum amount of energy required to emit.
Correct. It is minimum amount of energy required to eject outermost electron from metal surface. What is work function? Minimum energy required to eject electron from metal surface. We represent it by phi naught. Okay. So phi naught is energy, right? And can we represent energy in terms of hc by lambda? Obviously, any type of energy we can represent by hc by lambda, right? Because hc by lambda also have dimensions of energy. Any doubt? And this can be written as hf naught. Okay. Understood what is work function? Now, what do you mean by threshold wavelength? Wrong. Lambda naught is threshold wavelength, but how will you define threshold wavelength?
Minimum wavelength required to check.
Maximum.
Maximum wavelength. जहां मैंने 12th लिख दिया ना वो स्कूल में आएगा. Now threshold wavelength is corresponds to lambda naught, and lambda naught will give you what is lambda naught. But your lambda naught is wavelength of that radiation which will give you minimum energy to eject electron. What kind of energy it gives? Minimum energy. So if energy is minimum, wavelength should be
Maximum.
maximum. So threshold wavelength is the maximum. It is the maximum wavelength which can eject electron from metal surface. Understood? Now write point number 4. It is also very important for 12th. Cutoff frequency. What is this cutoff frequency?
F naught.
F naught. So what you would like to comment about F naught? You want minimum energy. Phi naught you want minimum. So F naught should be
Minimum.
minimum. So what is F naught? What is cutoff frequency? It is minimum possible frequency which can eject electron from metal surface. Understood? Understood everyone? Any doubt till this? आगे बढ़े? Okay. Completed writing? लिख गया ये सब कुछ? लिखते तो तुम लोग हो ही नहीं है ना. खैर वो आपको डिसएडवांटेज है. नोट्स कंप्लीट नहीं करोगे तो बहुत तकलीफ होगी बाद में. मेरे हिसाब से तो लिखते जाओ. कौन कौन मेरे साथ लिख लेता है? If you are writing with me, click on yes. Okay. Do not leave anything for later. Okay, write it with me. Okay. Now write fifth term. Very important for 12. Intensity of incident radiation. This is important for NEET and mains also. What do you understand by intensity?
Energy per unit.
Total energy
Per
per
unit
unit, yeah, per unit
time.
time. Okay. So sorry, Ucho. Now energy of one photon, do you remember? Energy of 1 foot. Energy of 1 photon is Hc by lambda. So what is energy of n photons?
NSC will
NHC by lambda.
Correct. So this is total energy and Hc by lambda, right? Understood? So intensity must be equal to n Hc by lambda upon area into time. Understood? So intensity of incident radiation is proportional to number of photons. Understood, bacho? Intensity of incident radiation is proportional to number of photons. Any doubt in this? And one of the our observations says, if you want to increase current, you will have to increase intensity. And intensity and current will increase in same proportion, right? So one of the most important observations says the photoelectric current is proportional to intensity of incident radiation. So we make graph between these two. What kind of graph we will get?
constant.
Photocurrent and intensity on x-axis. Graph should be straight line. This is very important. Draw this graph. Now what intensity, mainly intensity depends on what?
Numbers of foot.
Numbers of photons. The photocurrent, I know this is written already in your copy, but write it once again. The photocurrent is dependent from frequency. That is, frequency means energy of incident radiation. Because if you increase frequency of incident radiation, means you are increasing energy of incident radiation. अरे समझ आया बच्चों? Any doubt? Any doubt till this?
Yes.
Okay. Anyone would like to tell me another formula of intensity?
इलेक्ट्रिक फील्ड वाली. इलेक्ट्रिक फील्ड वाली.
No, वो वाला नहीं, इलेक्ट्रिक फील्ड वाला नहीं रहेगा. एनर्जी पर यूनिट एरिया पर यूनिट टाइम. तुम लोग केमिस्ट्री में
Upon area.
क्या पढ़ के आए हो भाई? Intensity is equal to energy upon time means power. Power upon area. You got another formula for intensity. Energy upon time is power, no? Right? So intensity is equal to power upon area. Understood? So Abhi, what kind of question can come from for this formula of intensity? A very tough question they can make. find number of photons coming out from a yellow color bulb. Of power 100 watt. Find number of photons coming out per second. Okay, can you try this question? See, you write both the formula of intensity. One of the formula says that intensity is equal to NHC by lambda into area into time. And your other formula says that intensity is equal to power upon area. Right. So you can write NHC by lambda area, put T is equal to 1 because they want number of photons. They want number of photon.
Per second.
That's why you can put time 1. Okay, Sinchna. And
Yes, sir.
power upon area. So area will get cancelled. Now you put value of power and value of H. 6 point. What is value of H? 6 point?
6.6 into 10 to the power minus
34.
3 into 10 is power 8 divided by 5000 Armstrong. Means 5000 into 10 is power minus 10 is equal to 100. You solve this to get value of N. Understood? This is a very important question for NEET and mains. Understood, bacho? Any doubt in this? Okay. आगे बढ़े बच्चों? Okay. प्रणव में समझ आ रहा है? Nitish, is everything all right? Ganesh? Okay.
Yes, sir.
That's good. Okay. Now answer my next easy question. Work function of a metal is 3.1 electron volt. Find threshold wavelength. How will you solve this? Say work function is equal to hc by lambda naught. Do you remember this? But if work function is in electron volt, if work function is given in electron volt, you can write here 12,400 divided by lambda in
Armstrong.
Okay. So this is also electron volt. Now you can solve this. Lambda naught is equal to 12,400 divided by 3.1. How much you will get? Use the calculator. Use your mobile phone. देख भाई कितना आ रहा है कहाँ है मोबाइल लेके बैठो जल्दी बताओ इज इट 4,000 आर्मस्ट्रॉन्ग बैठ जा वहां पे बैठ जाओगे क्या जाके नीट में सॉल्व करोगे कि नहीं करोगे क्या आराम से टीचर करेगा मजदूर रखा है क्या तुम लोग ने मुझे जल्दी क्या करो इज दिस करेक्ट परफेक्ट 4,000 ना
Yes, sir.
okay in a previous question if energy of incident radiation 5.1 electron volt, then find stopping potential. And maximum kinetic energy of ejected electron. This is for 12th. This is for 12th. Bacho, you are going to give 5.1 electron volt energy to a metal. And how much energy electron will invest in coming out? How much energy electron will invest in coming out? 3.1. So how much energy is left with the electron?
2.
2 electron volt. So that energy is with the electron in the form of what?
Kinetic energy.
Correct, correct. So out of 5.1 electron volt, 3.1 electron volt will be spent is with electron as kinetic energy of electron. Understood, bacho? So electron has how much kinetic energy? 2 electron volt. And this is maximum possible energy of electron. Suppose electron directly came outside without colliding with anything else inside the atom. Aman, see what is possible while coming outside, electron may collide with anything else and it can come with a lesser kinetic energy. Suppose electron were at the outermost orbit and it came directly outside. Suppose electron have this much kinetic energy. This would be maximum kinetic energy of electron. And I already told you, Ke, you can write kinetic energy is equal to EVS. Do you remember?
Yes.
E will get cancelled and stopping potential will be 2 volt. Understood? So you got stopping potential and maximum possible kinetic energy of electron both. This is very important for class 12 CBSE board. Already asked many times, same question. CBSE board में बहुत बार ये क्वेश्चन आया है. Okay. Now right. Done? हो गया? Okay. Now tell me one more thing. If we give more energy to the plate, if we increase incident energy to the plate, what else will increase?
Kinetic energy.
And with kinetic energy, one more thing will increase.
Stopping potential.
स्टॉपिंग पोटेंशियल. दादा v को वेलोसिटी मान रहे हो तो फिर मेरे हाथ जोड़ लेता हूं मैं आपके. कब? अच्छा इस वीक, पूरे वीक. हाँ तो छुट्टी दिवाली, वैसी दिवाली की छुट्टी है ना. ठीक है. हाँ ना, तो कोई दिक्कत थोड़ी है. इधर ही बता देंगे और क्या. आगे क्या हमको. अरे संदल अभी आए क्या बड़ा भाई?
नो सर, पहले से आया था सर, वो नेटवर्क इशू हो गया था बीच में, इसलिए लीव हो गई।
कल आया भैया आज।
तो पहले से था।
मैंने तुझे देखा नहीं यार, इतने दिनों बाद गली में आज चांद निकला है। चलो इधर देखो का भैया, ये वेलोसिटी थी, this is stopping potential. So if you increase energy of incident radiation, stopping potential will also increase in the same proportion. Could you understand that?
सर जितनी स्पीड से देंगे उतनी तो रोकने में लगेगी।
Obviously जितना ज्यादा तेज चलेगा उतनी ज्यादा स्टॉपिंग पोटेंशियल उसको रोकने में लग जाएगी, है ना? So write this note: if frequency of incident radiation increases, maximum kinetic energy of electron will also increase, and due to this, stopping potential will also increase. Understood, bachcho? Very important note. Now we are all set to learn photoelectric equation of Einstein in the next class. ठीक है? अभी homework लिख लो. Your homework is to watch my video of photoelectric effect. I'll send you. Okay, and I will send Diwali assignment in the group, or you can solve your Allen module. Solve Allen module in Diwali holidays. Okay, like you can solve wave optics, है ना? You solve wave optics, and atoms you can solve, and dual nature. क्या भेजना है? भेज देंगे ना, तो अभी भेज रहे 5 मिनट में, 2 मिनट में. Dual nature, this much you can do. Okay, physics, this is physics. And if you have completed your Allen module, then do it again. And if you have done it 2 times, then solve SC Verma for these 3 chapters. Okay, solve SCV. Understood? This is your Diwali assignment apart from speed lab practice. And in chemistry also, chemistry solve entire modules of 12th. Focus only on 12th. Maths and biology also solve. Calculus in maths, calculus and current 3 topics like vector, calculus and vector, and bio entire 12th biology module Allen. This is your Diwali assignment. And one more thing, read NCERT of biology 10 times, 12th portion only. Okay, only reading, nothing else. Okay, Ankur sir, आगे कुछ message? Yes sir, please.
Sir, thank you, sir. Hello, good morning, student. Am I audible to everyone?